take 2. I messed up the first one. You didn't see it, so you didn't know, so I didn't even have to tell you, right? So I want to find the volumes using the cross sections revolving about the x-axis for this function, y equals e to the minus x, and bound about y equals 0, x equals 0, and x equals 1. So the first thing I want to do is draw what does this look like. And so I know if I'm at x equals 0, then I'm actually up here at 1, right? Because e to the 0, anything to the 0 would be 1. And e to the negative x looks like this. It's a decay function. And so I'm interested in bounding this by these axes. That's my x and y equals 0. And then also at x equals 1. So what's happening here is when we say we're revolving it around, we're making this into a solid. So I'm rotating it around the x-axis. And let me just write that that's at 1, and of course that's 0. So we have this nice little formula, pi r squared. Get it? And so all I have to do is plug everything into this formula. So in this case, since it's about the x-axis, I'm looking at my x interval, which is from 0 to 1. Then I have my pi. And my radius, which is going to be this distance right here. Well, that's just simply the distance to my function, which my function is y equals e to the negative x. So I put e to the negative x, and I square it dx. So now we're to the point we just simply have, we want to find our antiderivative, and then plug in our limits of integration. All right, let's do it. So I'm going to pull the pi out front. And let's go ahead and bring this inside by multiplying it, so I have something a little easier to take the antiderivative of. And so I have pi out here. In here, remember the antiderivative of e to the negative 2x is e to the negative 2x, and then 1 over k, which is the negative 2. If you didn't remember that, you could use substitution, let u equal negative 2x, the derivative of negative 2x is negative 2, blah, 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 all that good stuff. But this is a nice little formula, 1 over k, e to the kx, all right? And so then I'm going to evaluate this from 0 to 1, which means I'm going to come down here. I still have my pi out front. I'm going to have negative 1/2 e to the negative 2 times 1 minus a negative 1/2, so negative and a negative, of course, is going to become a positive, e to the negative 2 times 0. Okay, so all I've done is this is that whole fundamental theorem of calculus where you're plugging in your f of b minus f of a. So going over here, I'm going to grab a color. And so from here, I certainly would have, I could actually pull out a negative 1/2 if I wanted to. Okay, I can do whatever I want at this point, or I can just throw it in a calculator, see if I'm going to get too low here. So if I actually factor out a negative 1/2, this becomes negative pi over 2. I'm still there on the board. So I factored out a negative 1/2, so this becomes e to the negative 2. This was a negative and a negative, so it's really a positive, right? I factored out a negative 1/2, so I have a negative left, minus e to the 0, which just happens to be 1. And I actually threw this in a calculator, and I got approximately 1.36. So a lot of it just depends on the final format you want to leave your answer in. But that's your volume. Ta-da!